everybody. I am going to demo for you today required practical 2, which is the measurement of an enthalpy change, and the reaction that I'm going to measure the enthalpy change of is that between copper sulfate and zinc. Okay, so to start with then, I need to measure 25 centimetres cubed of my copper sulfate, and to do that I'm going to use my glass pipette filler and just make sure that air, or rather I'm going to use a glass pipette and then I'm going to use my glass pipette filler. I'm just going to empty the air out of that, pop it on the top. This is a nice precise piece of equipment, and suck up that copper sulfate. When it gets towards the fill line here, I'm going to come down to eye level and just check the meniscus. Come on. Okay, here we go. Stop just before, turn to eye level, ever so slightly overshot that. 6 belts on there, perfect. Right, next then transfer that into the polystyrene cup and the beaker. Now, I actually spotted there I had an air bubble, and whilst that's not good, it's kind of good because it reminds me to talk about error. And the opportunity for error in experiments, wherever there's some measurement taking place, which let's face it, there always is a very common exam question. And if you have a bubble in the jet, that is a source of error. It's going to throw out your reading, and you're going to think you've got a larger volume than you do, because some of the space in that pipette fill is being taken up by air. There's only a tiny one, so I'm not going to worry too much. Right, so that's the copper sulfate measured. Next thing I need to do then is to measure the mass of my zinc. So I've got a top-down balance here, which is annoyingly kind of just out of shot, but just trust me on it. I'm going to pop my weighing boat on, and it's already on, but I'm going to zero it to make sure that I have accounted for the weight of the weighing boat. Now, in the method, it tells you to use about 6 grams of zinc, and that might seem kind of strange that the method is so vague and approximate, but it's absolutely fine. Oh, just over, I've got 6.22 grams. I'm just going to make a note of that, 6.22 grams of zinc. And the reason why it's fine to have that approximate value is because it has been worked out, looking at the mole ratios and reacting masses, it has been worked out the number of moles required for that reaction, and thus the mass of zinc required for that reaction. And so 6 grams will be way above the mass required for that reaction to go to completion. So we say that the zinc is in excess. And you'll have seen that before in lots of reactions where it says an excess of sodium hydroxide was reacted with, blah, blah, blah. So we know that we've got an excess, and so if we're slightly over or slightly under, it really doesn't matter. And part of your write-up for this experiment, part of the evidence sheet, asks you to prove by calculation why zinc is in excess. And so you'll need to look at your moles and your reacting masses for that. Okay, so now we've got everything measured out, and we're ready to go. Now, you need to measure the temperature change that is going to occur here, but you don't do that, or rather you don't add anything, for the first 3 minutes. So you can see here I've designed a results table. My results table has units in the headers, which means I don't need units in every single box underneath. Okay? We're going to record the temperature at time 0, which I already did actually, and I'll just pop the thermometer in there and double check, so 22 degrees. I'm then going to start the stopwatch and record the temperature every 20 seconds for 3 minutes. Now, I appreciate this doesn't make riveting viewing, so I'm going to talk you through this experiment from an examination point of view. So once I've reached my next 20 seconds, bear with me, I just need to record the temperature. Okay, should be pretty much the same. I'm going to do that for 3 minutes, and at 3 minutes I'm going to add my zinc. Okay? Now when I'm adding my zinc, I cannot record the temperature at the same time. So at 3 minutes you will notice, I'm sorry, if we'll just do that again. Okay, still the same, 22. At 3 minutes I add my zinc. I will have no value, and I've put there, I've put there zinc added. Okay, so there'll be nothing on the graph at that point. After that, I continue to record the temperature every 20 seconds until we reach 10 minutes on the stopwatch, at which point I stop and I then plot that data. Okay, so let's record the next one. We're still at 22 degrees here. I'm going to just indulge me. Let's imagine that 3 minutes have elapsed. I'll make this next reading the point at which I'm going to add the zinc. Okay, so I'm adding the zinc in and I'm stirring. I haven't recorded the temperature at that point. I'm going to wait for the next 20-second period, and when I check the thermometer next, it's quite rapidly increasing. It's gone up by 9 degrees. Okay? What you should then start to find the next time and every subsequent time that you check the temperature, next 20 seconds, check, yeah, oh, hang on, okay, that's gone up quite a lot. 5. Okay, we can hear it fizzing. I can see some bubbles, so I know some gas is being produced. So I'm going to continue, and okay. So, things to note is I'm performing this experiment in a polystyrene cup that has been placed inside a beaker. You can feel the heat coming off, that's an exothermic reaction. It's been placed inside a beaker. I'm going to stop there, okay? That's all I'm going to do for the rest of the experiment. The polystyrene beaker is quite a good insulator, but putting it inside a glass beaker makes it a better insulator. And this is an incredibly common question for this practical. Your biggest enemy here, you're trying to measure an enthalpy change, so your biggest enemy is heat loss. Okay, so you need to do everything you can to reduce that heat loss. And so using a polystyrene beaker, which is a good insulator, is one way of doing that. Placing it inside a glass beaker, which improves the insulation, is another way of doing that. And a common question would be perhaps to suggest a third way, and the obvious thing to do would be to have a lid on that. Another question I've seen asks you why the error associated with the top pan balance isn't really important. And if you think about what you're using your top pan balance for, which is to measure the mass of the zinc, we've said the zinc is in a large excess. So actually, if that top pan balance isn't totally precise, the impact of that on your experiment, on your recordings, is kind of neither here nor there. Okay? Right, I'm going to stop the video there. In the second part, I'm going to plot a graph of results and talk you through how to do that, areas that marks are frequently lost. Okay?